Good day, this is Joseph Lanry and I welcome you to my YouTube channel. In this tutorial video, we'll be looking at how to conduct descriptive statistics and how to interpret descriptive statistics. Descriptive statistics is one of the important components of regression analysis. It essentially describes the main feature of the data set, which provide sophisticated information to a data analyst on the nature of the data and whether or not the data can be reliable to provide a valid result in its raw form, or whether there's need for transformation. Sometimes it suggests the appropriate methodology. Okay, without wasting our time, I'd like to demonstrate to us how to conduct a descriptive statistics. Okay, I have my series there. My series there, the scope is between 1981 to 2021. Okay, for one observation. My series there has sectoral contribution to GDP, Greek contribution to GDP, industrial contribution to GDP, and service sector contribution to GDP. All right, so I'm going to click on a Greek sector, a Greek GDP contribution, and I'll hold on the control button. Then I click on the other variables, and then I click on the enter button. This give me open the series in the spreadsheet. Okay, I come to view. In the drop down menu where I see descriptive statistics, I'll go with the individual samples, and voila, we have the descriptive statistics result. Now, this descriptive statistics result can be interpreted, classified into three different components. The part that deals with the central tendency, the part that deals with the variability, and the part that deals with the distribution. Each of these components gives us meaningful insight into the nature or the characteristics, features of the series. We have mean and median, they are measure of central tendency, and they give us a representative figure of the series within the scope considered within 1981 and 2021. For instance, we can say that on the average, the agri sector contributed about that this series are in billion. Okay, they contributed. The agri sector contributed about 8,473 billion to GDP annually. Okay, so annually this sector contributes about 8,473 billion annually to GDP. Okay, industrial sector contributed about 12,216 billion annually to GDP. Okay, the same goes for service sector. Median also it measures average. Okay, it gives us a representative figure, a figure we can use to represent the series. Okay, for the 41 years observation. All right, then we have the maximum, the minimum, and standard deviation. This measures the variability. It provides us insight as to whether or not we can rely on the mean, the central tendency. Okay, minimum and maximum, the difference give us the range. Okay, and range essentially give us idea of whether or not there is presence of outlier in the series. Okay, if there is outlier, then it means that the mean representative might not be reliable. Okay, because outlier is going to overshoot the average figure. We see that the minimum is 2,303 and the maximum is 18,738. That's about 16,000 difference. Okay, that might intimate us of the presence of outlier. Okay, the minimum here is 8,255 to maximum of 16,000. We say the same here. The minimum is 5,000. The maximum is okay. That brings us to standard deviation. Standard deviation essentially tells us how dispersed the data is in relation. The data, each of the data is in relation to the mean. Okay, lower standard deviation means that the data are clustered around the mean, and then the mean are they're more reliable. Okay, in that case, but when we have high standard deviation, mean the data are spread out, and that makes the mean less reliable. In that case, the median might be more appropriate. You might want to look for a methodology that adopts median in establishing relationship between variables. Example of such is the quantile regression. Yeah, contour regression analysis. And then we'll come to the third part, the distribution, skewness, kurtosis, and Jacobera. These three components, they look at the distribution of the series. Kurtosis look at the thickness of flatness of the distribution of the series. The skewness measures the degree of symmetry of the series, but we won't be interpreting it because the information skewness and kurtosis are what we adopt in conduct computing Jacobera. Okay, so Jacobera essentially gives us information. We can get information about the distribution of the series using the Jacobera alongside with its probability value. Now, the normal hypothesis for normality test is that the series are normally distributed, and we know that when our p-value is greater than 0.05, we accept the null hypothesis and reject the alternate. Okay. Remember that I said the null hypothesis for normality test is that the series are normally distributed. Now, before I go, you should know that you conduct a descriptive statistics test on the raw data, not the transform data. The raw data, that is very important. So now, here probability is 0.09. We accept null hypothesis. We say series are normally distributed. I group to GDP series, the normally distributed. 0.27 normally distributed is greater than 0.05, right? And then 0.5 is marginally big. The margin, yes, we accept that the series are normally distributed. Okay, so this is descriptive statistics. This is very important because it gives us meaningful insight into the nature of the data and it guides us going forward. It tells us whether or not we can rely on the data in its raw form or there's need for transformation. Okay. So it is very and then it could also suggest methodology. Like when you realize that the standard deviation is high, it means that the mean might not be reliable. Okay, so you could either transform the data or you look for other estimation techniques that make use of median establishing relationship among the series. Example is the quantile regression. All right, that will be all for now on the descriptive statistics. If you are just joining this channel, I mean you're watching this channel for the first time, I will encourage you to subscribe to my YouTube channel to get update when I drop video. And for those that are regular on my channel, thank you for watching. Please drop a comment, like, and share with friends and colleagues. Thank you. See you in the next video.